here's your hint for number 4. So we're going to be going through this process that we outlined for static equilibrium with rotation. So the first thing you're going to want to do is draw your free body diagram. So we have our two tensions acting up. We have this object acting down, and we also have the force of gravity of the beam itself acting in its center. So we have these two forces. Note those aren't at the same location. The beam is at the center of the beam where the object is split between the two tensions. So make sure you get those in different places. The next thing we need to do is label all the segments. So because the two tensions are 0.8 apart, this object is located at 0.4 from the end. Since the beam is 1 meter long, it must be located 0.5 meters. So that makes this 0.1. This also over here, so this tension we'll note is 20 centimeters in from the end, so 0.2. And the rest of the distance to the center of the beam would be 0.3 to make it a total of 0.5. We want to label all of those independently so that we can add them back up later as need be. We need to choose an axis of rotation. Since we're finding tension 1, I would choose it over here at tension 2. And then you need to identify, is that a positive or a negative torque? So we have 3 options available to us there. We can use the old right-hand rule, where you point from the axis of rotation to the force, put your F finger in the direction of the force and which way your thumb is pointing. So if this was on my thumb is pointing out or away, or if I'm looking at my paper on my table, it's pointing up, thumbs up, positive torques. So both those are positive. I go over to this one, but my F finger's got to be pointing in the direction of the force, so I got to do this. Thumb into the board, negative. Your other option is the pencil trick. That's the one where you hold your pencil at that axis of rotation, push like you're the force, and see which way does it rotate. It rotates, in this case, counterclockwise, which is my positive direction, or if I push like I'm T1, I see it rotates clockwise, or my negative direction. And then the last one for the wordsmiths out there, if the force is to the right of the axis of rotation, the direction of the force is right or correct for the direction of the torque. And if it's to the left, it's flipped. So positive forces, negative torques. Negative forces, positive torques. They're flipped on that side. Once you have your picture, then you're going to start generating those equations. I'm going to leave that up to you to generate those equations though. There you go.